Greg here again with some bonus content with Evan You. When I sat down with Evan, I showed him this slide, which should look familiar to you if you watched the last lesson. I asked him to walk me through his rationale for how things are laid out, and what I ended up getting was an amazing tour of the source code from the guy who wrote a lot of it. It was pretty impressive. I think you'll like it. And at the end, he even talks about some of the future plans for the Vue.js source code. Check it out.
Right, so every Vue app starts with a new view, right? And this happens in your main.js or in your index.html. And the Vue constructor is located in source core instance index. And it's very simple. It simply calls this underscore init. And this underscore init is the main sequence that happens when every Vue instance is created. And inside init, in addition to init state, I can actually, so let's take a look at this. Init, we can ignore things that are not super important. So this part is actually a short path, a fast path for some internal optimizations, because when you instantiate a large amount of Vue components, dynamically merging options can be quite costly. So when we switch to this for internal components, it actually sped up the component instantiation time by a fair margin. So if you actually read the source code, you'll notice a lot of places are these little optimizations that are added on over time. So this is why, like, when you read a project that's been around for a very long time, it's likely that you notice the code is not super clean. There will be edge cases or dirty patches here and there.
Right.
Because over time we will realize we can make a little tweak here to make things a little bit faster, and over time it just adds up. It's kind of this is why you have to do big refactors when you have a code base that's old enough. So init proxy. So this is interesting because Vue 2 currently already uses proxies, but only in browsers that support them. So what does this proxy do is it actually uses the hash trap to detect property access that does not exist on your current component. So let's say you misspelled a property in your template, right? So you meant foo, but you spelled bar. Bar doesn't exist on your component. So this proxy, this render proxy, will be initialized here in development mode and detect that you are trying to access a property that doesn't exist and warn you about it. So this is using proxy during development for development experience improvements. And if we're able to, say, use proxies everywhere, there are a lot of opportunities we can provide even better development experiences. So now we have init lifecycle. So this kind of sets up and tear down stuff. Init events is about custom events, the event handlers that you do via $on, $emit. Init render actually sets up the render and update methods on the instance. Then we call before create. So this internal sequence is actually pretty useful. If you read the source code, this is the part that will probably be most practical, that will help you directly in your day-to-day code, because understanding when these lifecycle hooks are called kind of help you understand what you should or should not do in these hooks, right? So for example, plugins like Vuex and VueRouter inject their properties inside the before create hook. And before create hook is called before state is initialized. This means these injections will be available to you inside your data function. So you can directly use store state in your data function to initialize your component state. So this is injections, provide inject, and then call hook created. So created is called after state is initialized. This means in the created hook, or all props have been initialized, or data properties have been initialized, and all methods have been installed. Because if we go into instance state, you'll see that init state calls init props, init methods, init data. Note props are initialized before data. This means you can use props inside your data function, but not the other way around. You cannot use your data inside, say, a props default function, because props are resolved before data. And also, computed properties are resolved after data. This means you cannot use computed properties inside your data function. But you can use your data properties inside computed, right? Because that's much more, it's much more common for a computed property to rely on your data than the other way around, right? And finally, we initialize all the watchers. So that's watchers registered through the watch option. So we traced all the way back to init state and init data. Init data is the part where we actually take your VM $options.data, right? So if this is a component, it will be a function, and we will invoke that function with the get data. So if data is not a plain object, we actually throw a warning and tells you that it should return an object. And finally, we will try to proxy the data properties on your component instance, right? So if you have a foo property in your data object, you can access it on the instance as this.foo, right? This is because we are proxying this.foo to this $data.foo. So this is the place where we actually perform this proxying. And by proxying, it actually means we're calling object-defined property on the component instance, right? We also kind of make sure you don't have conflicts between your data, your method, and your props. And finally, we observe the data, right? This is the the simple observer that we talked about earlier, right? The deps, the auto run, watching, all that. So this is the place where this raw data object actually becomes reactive and starts to register dependencies if it's used inside a collection, watchers computation function. Cool. So then we go into the observe function, and we have an observer class. This is really just there to help organize the code a little bit, but the meat of this is the value that's being observed. We will recursively iterate through all the keys inside this object, and then convert each property into a pair of getters and setters. Inside the getter, this is where we are able to call dep.depend. Dep.depend essentially means collect this property as a dependency for the current running computation. And once this property is collected as a dependency to the running computation, the relationship is actually a bit interesting, because the dependency is collected as the computation's dependency, but the actual relationship is the reverse. The computation is registered as a subscriber to this dependency. Make sense? So the computation, whatever work, let's call it work, the work that's being done is a subscriber to a dependency that it relies on. So later on, when we mutate the data, triggering the setter, and eventually calling dep.notify, the dep will notify all its subscribers, and the subscribers are work. So you mutate data, work gets done. So in the future, we will consider actually making this observer thing a standalone package that we can use in other contexts, or even make it swappable so that we can have a different implementation. So for example, in Vue 3, we can have two builds, one using the proxy-based observer, one using the old ES5 getter-setter-based observer. So the older one will be compatible with IE 11, and the new one will only support Evergreen browsers.
Nice. Thanks for watching. In the next lesson, you're going to dive into template compilation and how to write your own render functions. This is powerful stuff.